Okay, in this section we're talking about isosceles and equilateral triangles. Now, there are certain things that you need to know about them, because not only are we going to be using these properties, but we're also going to be doing lots of proofs in this section. So, the first three things that are on the board here, we have the definition of isosceles triangle, the isosceles triangle theorem, and the converse of isosceles triangle theorem. Now, I color-coded these a little bit as well to go with the diagrams. But the first one, the definition, all you know when you have an isosceles triangle is the fact that at least two of the sides are congruent. So, isosceles triangle is a triangle with at least two congruent sides. Now, if you are talking about the isosceles triangle theorem, that also tells you about the angles in an isosceles triangle. So isosceles triangle theorem tells us that if two sides of a triangle are congruent, then the angles opposite those sides are also congruent. So in the diagram, I color code this so that the if part of the statement is green, the then part is red. We have our triangle in green, and we have the two congruent sides marked in green. So if we know we have an isosceles triangle, then the sides that are opposite, or the angles that are opposite those sides, must then be congruent. So these two angles are congruent because they're across from those two sides. The converse does the exact opposite. So notice, the colors have been reversed a little bit here. We still are dealing with the fact that we have a triangle. That doesn't change. We still have a triangle. But the converse of isosceles triangle theorem switches the part about which parts are congruent. So if two angles of a triangle are congruent, then the sides opposite those angles are congruent. So here, these two angles are marked in green because we knew that part first this time. And if that is true, then the sides opposite those angles are congruent. Now it's important to know what order you can do these in, because again, we're going to be using these in proofs. So given the definition of an isosceles triangle, we know sides are congruent. Once we know that sides are congruent, and once we're dealing with an isosceles triangle, then we can use the theorem that states the base angles are congruent. If we're told either of these two things first, if we had to use either of these two ideas first, we cannot use converse of isosceles triangle theorem, because for these, we already know we're dealing with an isosceles triangle. For converse, though, if we were to state that we had an isosceles triangle after knowing the angles are congruent, so the angles are congruent, then the sides are congruent, now at this point we know we have an isosceles triangle. So after using the converse, you could then use the definition to say this is an isosceles triangle. So again, when it comes time to do our proofs in this section, it's important to know which ones you can use after each other and which ones you can't. Now, this next one, I think it's kind of in a little bit of a misplaced area. If you wanted to, you could pause the video right here while this is on the screen and make sure you get those copied down for your notes. And then whenever you are ready to move on, you can listen to this next part. So, the next theorem, I think this one is a little misplaced. So, isosceles triangle bisector theorem. Our book doesn't prove this because it can be proven, but it usually isn't proven until after we've done the next couple sections that are in this book. So the isosceles triangle bisector theorem. The book doesn't give it that name. That name came from an old book. So in your book, it's just called Theorem 4-2. If a line or line segment bisects the vertex angle of an isosceles triangle, then it is also the perpendicular bisector of the opposite side. So again, I labeled what they gave us in green. We have an isosceles triangle, and then once we had the isosceles triangle, we knew that this was the bisector, and if that's the bisector, this side is going to be congruent and perpendicular to that third side.
You get 2 more boxes.
Okay, I'll come get them. Thank you. So we know that these two are congruent and that it's perpendicular to that third side. For the bottom figure here, this is just going over the ideas of what parts each of the things are called, because in this one it actually used some words that you might not be familiar with. So we had vertex angle. The vertex angle is the angle at the top of an isosceles triangle between the two congruent parts, which are called the legs. The base is the side that's across from the vertex angle, and the two angles that border it are called the base legs. So again, those are some keywords that you should know. Based on this and just general ideas of, based on the general ideas of what we had done yesterday with isosceles and equilateral triangles, you should hopefully be able to complete the homework for tonight, which is on the board. Page 159 to 162, problems 12, 15, and then 17 through 23, and 29 through 30.